Hello, in this section we will give a summary of our project and presentation. What did we learn from association analysis? Found that there's a trade-off between the granularity you set in your taxonomy and the minimum metric levels, support, and confidence that you choose in your models. Let me give an example. If you set your granularity high, we had gone with IBD, you can set your metric levels a little bit higher. Maybe you want to have a 1 for support minimum. But if you had your granularities a lot finer, then you wouldn't get very many rules with that 1. So you might end up setting your metric level to 0.3. So you can't just look at one or the other value. It's how they work together. And so it makes it harder to be objective in deciding, oh, this is a good rule or this is not a good rule. So you need some domain expertise about your subject to say, that seems like a reasonable rule, or that's an inexplicable rule. That's something we didn't expect to find, and doesn't seem to have any relationship out in reality. Also, we found with Enterprise Minor, it would not run the actual association analysis modeling, validation, and test sets, so we had to create our own workaround for that process to occur. And as I said, without domain knowledge, it's hard to evaluate the results from your association analysis. You've got to know a little bit about the diseases you're looking at to say, well, that seems reasonable or not. Also, that domain expertise is valuable for text mining. Text mining we used, instead of the ICD-9 codes, the related text to that. And it's helpful to know what words need to go together in phrases so that it's really a phrase is one unit. And that you need some more domain expertise and at least some knowledge of the medical terminology in order to set what's a phrase, what's a word. We expected to see more, I'll call them homogeneous clusters. We expected clusters that would be 90-some% UC patients and another cluster 90% CD and another cluster IBS patients. But that's not what happened. We did have clusters that were 85 to 90% UC or CD. But then we had quite a number of other clusters where it seemed the definition was what did they have in common? Well, they were admitted for diabetes or because they were pregnant, and they also happened to have a chronic condition, IBS, CD, or UC. So the clusters came out differently than we expected, but it was still very useful information and very usable for our analysis. We did find with the expectation maximization clusters, they were clusters 13, 14, 12, and 4. Usually the primary reason for admittance was Crohn's disease or ulcerative colitis. And we saw with those clusters that the other conditions in that cluster, for patients in that cluster, would be blood loss, hemorrhage, anemia, abscess, and fistula, which are very much expected or, unfortunately, occur often with CD or UC. And we found those other clusters that I mentioned before where primarily the patients had diabetes. They may also have UC or CD, but there was quite a more heterogeneous blend of patients in there. And with IBS, well, IBS was not often a primary or secondary diagnosis, so we didn't really find a cluster that was mostly IBS patients. Well, which is kind of models the real world. IBS is a diagnosis that's made after they've ruled other things out and they can't find a structural problem that's causing the digestive diseases. It's a functional disease. So along with the saying that the domain expertise was needed, what we did was we went and looked at patient information that's readily available from different foundations geared toward helping patients with the different diseases. For Crohn's and colitis, it's the CCFA, Crohn's and Colitis Foundation of America. and IBS, sorry, I don't remember the name. It's in our written paper as a reference. There's a patient information website for IBS. So we went out and found typically what a patient or their family would know as conditions associated with that disease. So let's talk a little bit more about the comparison of the association analysis and text mining results. Found there's no metric, there's no single stat to say, well, here's association analysis rules and here's the text mining clusters, predictive modeling, and compare the two and we'd say one's higher than the other. That doesn't happen that way with association analysis and text mining. So we've kind of taken more of a complementary approach. What information did we get from association analysis and similar information from text mining? To add those together and to look at the outside domain knowledge and to see what was reasonable. Separately within the association analysis and text mining, we also did predictive modeling to look for important variables. Association analysis was more for classifying. The text mining was more for making a prediction itself based on the variables. What were the common findings with text mining and association analysis? For ulcerative colitis, we found the blood loss, anemia, weight loss, dehydration, completely expected and found in patient literature. For Crohn's disease, anemia, fistulas, hemorrhage, intestinal abscesses, and obstructions, also all found in patient literature. Let's consider where we thought we were going to end up and where we actually ended up. The data that we used is the same source, the KID 2009 data from HCUP. We did create some derived variables related to the taxonomy, UC, CD, and also the codes, creating flags. Did this person have this particular disease or not? In text mining, we recoded, reformatted from the ICD-9 codes to actual text phrases, and we did some grouping of the codes. Some of the all 555 ICD-9 codes, we're going to use the level of saying that all those codes, that's Crohn's, and we're going to replace all those individual codes with a code that means Crohn's disease. Now, in our original write-up, we had an objective, and in that objective we said we would look for known conditions or known relationships. That known wasn't really specified enough. What's known? Who knows it? Depends on who you are. So we ended up doing literature searches of that patient literature, and we identified known as those conditions that were found in patient literature, as opposed to conditions maybe that gastroenterologists, pediatric specialists would know or expect to see as a condition on a Crohn's discharge record. So we performed literature searches in both patient information and in more sophisticated medical research results. Also with the known, it's all tied in there. What does known mean? Is it supervised or unsupervised? Really, if it's going to be known, it's more supervised learning. That occurs afterwards when we're looking at the results from the association analysis and text mining. Does it seem reasonable? Now, if you're searching for unknown, well, then it's not going to be supervised, and that's how we're deciding what conditions are unknown. And we decided along the way to add in predictive modeling to predict those targets in both association and text mining analysis. Also, issues involving scope as far as symptoms and conditions, the taxonomy. What do you decide is what level? Do we model disease or IBD in general? And that scope also came into play when you're looking at the left-hand side of the rules. There are many different types of anemia. Do we model them each separately or include them together? We ended up modeling them separately because anemia could be due to blood loss as well as not absorbing. What are the impacts of medications? Well, some of the medications you take for IBD diseases cause some of the conditions that you see. So do you say, well, if you've got low potassium, Is that because you have IBD, or is that because you take a medication that causes low potassium? The same with disease severity. Disease severity and what conditions you have for inflammatory bowel disease, there's a relationship there. The more severe cases will have, you may start out with dehydration, and that might bring you to the hospital. But as you go on, you have more absorption problems, more imbalances in your blood. You may end up with conditions like tachycardia or liver issues. And let's talk about the results that we found. We're going to determine which other ailments are closely associated with IBD. I believe we did that. We plan to discover how groups of IBD patients are alike and different, and we further hope to discover how groups of IBD and IBS patients are different to develop a diagnosis process that will better differentiate the two. So let's cover the common symptoms. We've discussed those before. Those are all the digestive disorder and associated weight loss symptoms. Then we had symptoms that were common that were not in the patient literature, the gastritis, reflux, and asthma. Those were common for all three. Then we can look at Crohn's disease in particular was characterized by abscesses, fistulas, fissures, and intestinal obstructions, UC, hemorrhaging, cholangitis, C. diff, pancreatitis, and tachycardia. So let's see, did we find groups of patients that were alike or different? Yes, we did, because CD patients tend to have those abscesses and fistulas, and UC patients have a lot more bleeding and liver and, with more severe cases, tachycardia issues. We also found IBS patients tended to have headaches or migraines on their discharge records. And comparing IBD and IBS, what's the difference? Well, they all have those common digestive symptoms and pain. The difference seems to be those malabsorption problems. The anemias, the low potassium, all those blood electrolyte type of problems. That if you've got abdominal symptoms, digestive symptoms that are going for a while, and your blood work was also coming out abnormal, doctors should consider having the patient evaluated for an inflammatory bowel disease. Of course, if they have any of the CD or UC particular conditions, bleeding, abscesses, they should definitely be evaluated for IBD versus IBS. We said our objective successful if known related diagnoses are verified and two or more unknown relationships are found. So did we find known related diagnoses? Yes, very much so. All of the common symptoms and those symptoms in particular for UC and CD. So it seems that association analysis and text mining are providing fairly explainable results. I'm not finding inexplicable rules. But that does bring us to the unknown relationships. How do you define unknown? Well, we decided to look at it and say, well, if a patient or their family could find out about it from reputable sources, that's going to be a known relationship. And we're going to consider those conditions that involve other organs, like the heart or the liver, to be a type of unknown. Now, we found that tachycardia, cholangitis, and pancreatitis have been the subject of research studies about IBD and their relationship to those diseases, and they have been verified in research literature. So if you were a pediatric gastroenterologist, you could look at our results as far as rules and say, well, yes, there is a relationship between tachycardia and cholangitis. What other unknown or inexplicable relationships did we find? We had reflux, gastritis, and asthma. Now, we had found some medical research papers that actually studied those, let's say. But there wasn't a consensus among the papers whether there's a definite relationship between reflux, gastritis, asthma, and IBD or IBS. So really, those are our unknown relationships that we would advocate there to be more hypothesis-based testing, or to have a study where you can go and check the medical records and see if people came in with reflux gastritis and asthma, or if they developed them while they were in the hospital, so we can see if there's a confounding influence there. So were we successful? Yes, we did find known relationships. And we have our two types of unknown relationships, those that a medical professional in the field would verify and say yes, but an ordinary patient would not know about. And then we have our unknown relationships that are really still under investigation by medical researchers, and we would advocate further studies. Thank you very much.